In this unit, we'll discuss systems of equations. A system of equations is simply two or more equations that are graphed in the same coordinate plane. When we talk about finding the solution to a system of equations, we're simply looking for the point or the points where the graphs intersect. Depending on the type of system, there could be no solution, there could be one, or there could be more. A system of linear equations is one composed of two lines. When we talk about a system of linear equations, there are three different types of systems we can have. First of all, we can have a system where the lines are parallel. Now, if the lines are parallel and we're looking for a place where they intersect, then they're never going to, so this solution has no, or the system has no solution. A second option is where our lines intersect at one point, a system like this one. In this case, that one point where the two lines intersect is the solution, so the solution to this system would be the point 2, 0. That is the only place these two lines will intersect, so this system has one solution. The last option for a system of linear equations is if we have two lines that lie on top of each other. Now, in this case, every single point along that line would be a solution to the system. So there's way more than one. In fact, there's so many we can't count them. So since every point that is on that line is a solution, we say that we have infinitely many solutions. We can't just identify one. Now, in addition to systems of linear equations, we could have a system of a quadratic and a line, in which case the graph would be a parabola for the quadratic and a line. We have a couple of the same options. It's possible to have a quadratic and a line that do not intersect, in which case there is no solution. It's also possible that your quadratic, your parabola, and your line intersect at only one place, in which case whatever point this is, that would be the solution to your system, and there would be one of them. Now, the third option is different. It's impossible to have a line and a parabola where the entire curve is exactly the same. However, it is possible to have a line and a parabola that intersect at two different points, as in this case, the point 5, 8 and the point -3, are places where the line and the parabola intersect. So this has two solutions, two different points that would satisfy both equations. We also will investigate a system of a circle and a line. We have, again, the same type of solutions in that we could have a circle and a line that never intersect, such as the first picture, in which case there is no solution to the system. We could have the case where we have a circle and a line that intersect in 2 points. In this case, there are two solutions to the system. And we could also have the option where the line is tangent to the circle, meaning it touches the circle in one place and one place only, so we have one solution to the system. So our options for a system of circles and lines is no solutions, two solutions, or one solution. Exactly the same as the options for a system of a quadratic and a line. In this unit, we will be focusing on two approaches to finding these solutions. We'll solve them algebraically, as well as take a graphical approach and be able to look at the graphs of the system and determine the points where they intersect.